My name is Nehal Singh and I'm fourth year student at IIT. This is my fourth year project. Student ID is 2019-1006. UOWID W1809822. So I'm going to present about DFVote, which is a blockchain based federated learning system for a voting system. So this is basically two niche topics, which is blockchain and federated learning system. Which uses both of the technologies to improve the performance of one aspect. So here I'm going to present a solution to improve the security and privacy and transparency of voting analysis, I'd say, and running problem that's been in this not in the country, in the whole world. So as we can see, like with the improvement of AI and big data and machine learning in the world, it's been used almost everywhere, and it's been a revolution here in the 21st century. Uh, and it can be used for several purposes, like good things into data. You could use the data sets and data for curing diseases and many predictions done, but it could be used adversely as well. So one main thing in doing in many Western countries, I'd say like more developed countries, is political parties or election when elections near, they do voting analysis or voting turnouts. So many different political parties use the voters' data or the election general public's data to train some model and do an analysis regarding the voter turnout or voting predictions or like behavioral analysis of basically voters or general public. So it's an issue for the general public because obviously people do not want their data to be publicly or used by any other people to their own gain. So it's in literature also there have been serious privacy issues that has been highlighted in many researchers regarding this in politics and in many, not even in politics, in many other places. So here using federated learning comes in handy. So what federated learning is a superset of machine learning. So what's the difference between just conventional federated machine learning and federated learning is it's a type of distributed learning. So what distributed learning is, you could train one model using different data sets or different models. So what federated learning highlights is it conserves the privacy and the privacy of the data or the owners of the data. Meaning, if we consider a hospital where a disease prediction is done, so using data sets of different hospitals, one model can be trained. So it can be done like this. So there's a global model. After that, the global model is sent to the several hospitals, and then they train individually in their certain hospital. And then after training a model, there are model weights and model biases, so known as model parameters. These model parameters are then sent to the global model, and they are using a certain averaging algorithm or aggregating algorithm. They are averaged, and then hence a global model is made using that, and it can repeat for rounds and rounds to increase the accuracy. So the concept of federated learning is that basically training models individually and then sending the parameters of the models without sending the raw data. So here the raw data or like private data of general public is not exposed. Here only the raw data is sent and averaged, and it has been proved that the accuracy and everything is more than good here. And even Google has used this. First time they have used it in Google Keyboard to do many typing using typing predictions and stuff like that. So this is really a good solution that has been invented through in the new era, but it has its own disadvantages. Like you could compromise the data so easily. So even if you consider like a disease prediction or any little inconsistencies of data could really compromise the model in a huge way, which could affect the accuracy or the result of a model drastically. So the transfer of parameters is really vital because hackers or any mistakes that can be done could really affect the model. So that's where blockchain comes in handy. Blockchain and a distributed system is so basically it gives an immutable ledger. It not only gives the privacy and security, it is immutable as well. So if I'm gonna use, I'm gonna use IPFS as well. So IPFS is a distributed ledger system as well. So when it's distributed and immutable, even if there's an error, when training is done, you could really trace back and then figure out what the error was. And when it comes to hackers and compromising external parties, it's really the hardest job to because a blockchain has been proved to be more secure over the years. So here the main focus here is to integrate the IPFS and blockchain to the federated learning system to do more to provide more security and more privacy to general public. So as I said, like many political campaigns and voter has been they have been using the private data and micro targeting using their micro targeting tactics are highly like they are tracking the voter behavior and the traits. And as many researchers have proved that they have it's been a real issue in the world. So despite the challenge, despite like the advantages what federated learning has, it has its own challenges. I said so. Reliance of the central server is what makes it vulnerable to attacks and inconsistencies of the data. So doing incorporating it to a distributed system, hence IPFS and blockchain, it can really help the system and increase the privacy and the security. So there have been similar work that have been done. So there was a federated learning system with uh, blockchain used in COVID-19 prediction as well in 2021. So they have been used to enhance the prediction accuracy. So it was limited to medical data. So it had been like used by other fields as well. So there was some other domain agnostic libraries as well, which uses blockchain and federated learning system. So here, what I'm going to do is to incorporate that technology in a novel way, a novel flow for voting systems to so to increase the security and gain a trust between the general public and the political parties too. So the main research gap of this is no one has really existing solution never really addressed the specific needs for this voting analysis done. So this is it's going to be a novel flow for voting systems. So this system consider the system architecture or the system architecture basically is the presentation tier, which is the user and interface. So admins can log in and basically upload the data sets, which start the training purposes. So what the admin does is logs into the account or like the wallet, and then uploads the data sets and start the learning part. And then basically the federal learning occurs where you train the model, and then the parameters are stored in IPFS, and then the hash is stored in blockchain. And then after that, the federal learning model retrieves the IPFS hash, hash from blockchain, and then retrieve the parameters and then aggregate it and then create the final model. So that's the main architecture of the consist of this presentation tier, logic tier, and the data tier. So in the logic tier, only the federated learning and the model training occurs. In the data tier, is obviously the main distributed ledger system, which is IPFS and blockchain. So this is the concept map. So basically, it contains smart contracts, which for the storage and the retrieval of IPFS hashes, and for the voting, storage of voting as well. So it's the main heart of the blockchain, where you could automate storing and retrieving of data. And every time you store data or retrieve data, a certain amount of gas fee is reduced by your wallet account. So it can be a disadvantage, but uh, the security provides really can makes up for it. So that's the reason. So I have used IPFS because IPFS is free service. So if we consider to put all the model parameters to blockchain, the gas fee might increase. So saving the model parameters in IPFS and saving the hash in blockchain can be cost efficient too in this scenario. So the other sec is the interface which allows the admins to basically upload and start and aggregate the data sets to perform the model training, and the voting interface to for the users to add the vote. And the blockchain they here is done by the Ethereum network. So I'm gonna do it using the Anasha test network. And there the other sect is IPFS. So IPFS is the main storage where the model parameters are saved. And there's the other one, the federated learning concept. So basically, what it does is it takes the data set from the user interface and start training it, and they send it the parameters to blockchain, sorry, IPFS, and then retrieving it, and then retrieving all the parameters from all the data sets and combining and increasing the accuracy and creating a final model. So that's the main concepts of the system. So if we consider a chart, basically you start it and like several admins can log in at any time they want. So one admin can log in from station, they log into it, and it can be done simultaneously or whatever anytime they want. And then if the data is valid, you start in each station. Then what happens after training? The model weights and biases are pushed to IPFS. And after they are pushed, there's a hash generated by IPFS, which is unique to that. Only that hash can access that. So that hash, that security SHA hash is saved in IP blockchain. And you retrieve the hash from the blockchain. That it can be done simultaneously using another admin as well. And then after retrieval the model parameters from IPFS using the retrieved hash, it performs the federated averaging or any other averaging algorithm, aggregating algorithm to update the global model, and hence you can even use the model for your own good. So that's how the process flows in this system. So the implementation will let's go to the implementation part. So this is the home page for the DFVote system. So basically, this has two main functionalities, which means it has the button for the administrator to go on and then start training, uploading the data sets and start training the model, and start the federated learning process, and the user's functionality, which allows the user to go and vote. So basically, the admin functionality allows you to connect to a wallet and then using the private key. only the administrator can log in. So any other one other than the administrator can't log into this. So that ensures the security and it ensures who the authority who can only train the models. So here, as you can see, we have connected to one account. So I'm using Ganache local test network, which is a test Ethereum network which runs locally. So as you can see, there are several test accounts which has like Ether, and you could import this to do the demonstration purpose. So I have, as you can see, uh, uploaded one account. So it's here is this account. And I'm gonna log in using another browser. So using different MetaMask wallets, I'm going to log in different browsers, which mimics different voting stations or different election stations. So go here. This also say that the account and login, and it's a different account. As you can see, it's this account. They have login. I'm gonna go to. And then I'm going to connect to the wallet using another account, and in that way we can mimic three separate voting stations. So I'm going to start the backend server. So it's a fast server that runs in the localhost 5000. As you can see, the server is up right now. So here in the functionality, you can choose the administrator have the ability to choose files. So what happens is when voters vote, the data is going to datasets, and only the administrator have the power, the authority to choose the files and transfer the datasets into the training purposes. So you have created just dummy datasets. So it basically looks like this small dummy datasets which has like three rows, and these columns basically the basic demographics of the voters, like name, age, gender, region, and the preferred candidate. So this is just to demonstrating purposes. So I'm just gonna, so in this, I'm just going to create like fake data and a fake model, and just trying to demonstrate the usage of blockchain, the importance of IPFS and blockchain in this project. So I'm going to select one data set and upload it. And you can see here the post endpoint upload has been hit, and then you can start training it by pressing that button. And you can see here basically what happens is it puts the data into a data frame and then converts into a matrix, and this is uh, like the target y, and then basically converts the parameters and then trains the model, and then using like a neural network. And after that this converted into parameters and then sent into IPFS. So the IPFS which is saved here, as you can see, there's a IPFS hash that I have printed here. So basically, this hash is where the and the now trained models parameters are saved. So using that uh, hash, you could get the parameter. So I'm gonna do that with another account too. So if you go here, you could choose another station too. I'm gonna use here. You could upload it and then start training. When you start training here, then you can see again the new data. It's a new data frame, and then again the training process have the normalization, and then converting into tensors, and then converting into parameters, and then training, and then sending it to blockchain. And this is the hash, and these are the transaction receipt basically. So we could do the same thing in the other account too. So I'm going to select another station which has other data and start training it. And then the same thing happens using different data. So here what basically happens is what federated learning, the main purpose of federated learning concept, I haven't used any federated learning libraries. So federated learning is basically training one model at one station without sharing the data, and then only sending the parameters, not the raw data, only the data parameters, the model weights and biases. And then after you train the three separate models separately, then you send them to IPFS, and then after that, what happens is using the hash and the client address. So here in different accounts, we send the model parameters using different client addresses. So in blockchain, I have saved in the transactions accordingly to the client address and the IPFS hash. So in that way, we could using the client address, we could get the hash from the blockchain, and then after we retrieve the hash, we can retrieve the model parameters. And after we retrieve the model parameters of the three models, which means the three three voting stations. Then what happens is we average or aggregate the parameters and then create a global model. So that's what federated learning does. So it does not have a central server. What it has is the model is separately and individually trained in separate individual voting stations, and then the parameters are sent to IPFS. The main purpose of sending the parameters to IPFS and saving it in blockchain is because it, as we talked about, it has security, and it is immutable, so it's not changed. So if there's a possibility of model poisoning or any compromisation that can happen to the model, we could easily go back and trace it. And other than that, it's really as it is decentralized, it does not have a central. It's uh, it's it's really hard to a hacker or anyone to get get into or get compromise the model's performance. So that's why federated learning concept is a really important concept. So here we can see the three models are trained, and then after that, what we can do is so run the aggregate function. So the aggregate function. So what it does is it basically fetches the IPFS, the blockchain hashes from the client addresses, and then after taking the in this case only the three clients and the three respective hashes, then the it can retrieve the three more parameters or the weights and biases which is saved, and then aggregate it together and create a global model. So federated learning here, it can be done in many ways. So in further, you can train it again for several rounds, for one round, two round, three rounds to increase the accuracy. Or you could, when if you consider new data coming in, so you could train it for different rounds and rounds. So here I'm going to demonstrate just to see the purpose of the blockchain. And here, so here it is averaged, and then you can see the final result of the final global model. So that's how it happens. So in the code, uh, so this is basically the home page which contains here. I'm gonna start at the JS, which has the routes to the pages, and then this is the home page which basically has the two buttons, to admin and vote. And in the admin.js is the main core component. So as you can see, this is Nava, and here what in the user method inside that it initially it sets the account, which means the current account, which means the logged in account of the client, which means the client address or the address here. You this address or whatever address it's logged in, it's logged here. So account is set to that, and then the handling of the upload function. So here the upload endpoint here. So basically, what it does is it sends the file or the selected dataset file to the endpoint, and then this is a train function. What happens here is it sends the client address, the account. So using the use effect here, we save the account address, we send it here by. So as we use three different client addresses, I created this to uh, pass the as a parameter. So this function basically is to create connect the MetaMask wallet. So as you could see earlier, it does it really well, and that's the and this you can see this is basically the form. Here the contract ABR, this is the contract address. This is how you connect to the blockchain using the Web3 library. And this front end is to for the voting system. It basically just sends the store. It calls the store vote function from the smart contract and saves the input data. So we can see the so here this is the main the learning server which I upped in level of 5,000. Here this is the routing, the upload route. So this to upload the file. So basically, after we send it from the front end to this endpoint, this is the where it takes the file, the CSV file, and does the appropriate thing. This is the for the training route. Here it takes the file and then it extracts the client ID, and then what happens is the normalization and the machine learning part of us here. So here I'm didn't focus on the machine learning part because I'm going to mimic or do a fake using dummy data. So what this does is basically calls the load data function. So in load data, you can see it reads this file, and then it's created into a data frame, and this here these two columns and it's dropped, and then it basically created an X matrix and a target phi, and it returns it. That's what happens there, and then into a load set, and here the net meaning is just a basic neural network. And here, as you can see, it's optimized here. And then first, you can see here, I have converted this into like normalizing and then put it into data frames, and it's in this basically. And then you return this X and Y, and this is where you initialize the neural network. And then you can see I just printed here the training purpose. As you can see in the logs, this is training the model, and then it this is before. As you can see, I have been training the model, and this is the weights and bias before training the model, and after you call the train model functions. There, this is so after in here also what it does is basically a fake, a small mimicking of machine learning is just for one epoch. I was just calculating the loss and back propagating, and this is not the main part of course. So we're going to use, so here you can see after training the model in this function also, it basically puts the model as a parameter, and then inside that it creates like convert into a list, and it returns a dictionary. So that's how the model parameters are taken, and after that this pin to IPS function is called. So basically it takes the parameters, and here I have used the Pinata cloud. So they give you after logging in a secret key and an API key. So in that you could by you could put any kind of data here. So here you can see I have called that function here, and there's a hash that is returned. So, and then the hash that's returned from there is saved into blockchain with the client ID. In this function is it calls the store hash function, which is basically storing the hash. As you can see, it takes the client ID and the IPF as parameters, and then it's saved in here, and the number of clients is also there's an like an array. It's pushed. So that's how I save the hashes that's been taken from the IPFS. And then after that, the aggregating thing. And here also I have initialized the blockchain setup using this. First put the contract address. So the contract address is basically when you run deploy the contract, there's a contract address that is generated, and you have to put here the ABI that is generated in this JSON files. So you connect it, and then from the blockchain, we can fetch all the IPFS hashes. So if there are four or five or whatever, how many clients or voting stations we mimic, we can get it, get all the hashes, and then according to the hash, the model parameters can be written. So here in this function, it's fetching the data from the IPFS. So earlier it was for uploading the function. So using the hash, system to the parameter, and using the hash, we could get the, and this is just a function to average the parameters. So as I told, the main purpose of federated learning concept is to, after training each model, uh, we get the parameters of each and every model and average it. So this is basically an performance and average thing. So there are many averaging algorithms called Fed average and many others. So I haven't used them here. I'm just using a basic averaging just to show the purpose of the federated learning concept. So basically, I'm doing this just to show the usage of blockchain and how IPFS comes in. So that's how that model is basically trained, and then after training, sending the parameters to IPFS, and then basically getting the IPFS from blockchain, and then averaging the model parameters after getting it from IPFS, and that's how the main system works. So, so the main purpose of this system is not only for voting stations, but for the general machine learning systems as well. Because here it combines two innovative like niche topics, which is basically for the learning and blockchain, which provides a novel flow for voting systems and other systems. Because this voting analysis of one turnout predictions or behavior analysis, they are really being used in other countries as haven't been done in Sri Lanka yet, but it is a potential threat with the increase of AI as a whole. Anything can be possible. So I think this solution or this flow, let's say this flow of technology is can be really helpful in preventing those types of obstacles and creating a good secure and a trust, giving trust to both the administrators of the political parties and the general public as well. So yeah, thank you.